More than 60 million years ago, a 10-kilometre asteroid struck our Earth, producing a devastating 100 million megaton blast. What followed next was beyond human imagination. The impact of this blast created a gigantic hole in the Gulf of Mexico called the Chicxulub crater and wiped out over 3/4 of the world's plants and animal species at the time, including dinosaurs. To ensure that history doesn't repeat itself again, scientists have launched the Double Asteroid Redirection Test Project, which involves crashing expensive spacecraft into dangerous space elements. NASA and other prominent space agencies across the world are committed to several projects in space, many of which have been described as groundbreaking. There's NASA's Artemis mission to land humans back on the Moon after a long time. Elon Musk is focused on colonising Mars, and China is building a revolutionary space station that would be superior to the current International Space Station. But none of this would be possible if the Chicxulub event repeated itself again. Over the years, we've seen how dangerous asteroids can be, both in the movies and in real life. The impacts are all around us. One of the Earth's most important satellites, the Moon, is said to have been created by a collision between an asteroid named Theia and the Earth. This reportedly happened shortly after the formation of our planet around 4.5 billion years ago. Apart from creating the Moon, the collision caused several changes to some of the natural occurrences on Earth. To mention a few, it changed the makeup of the Earth's crust and the length of our days. So in other words, this collision had two sides to it. On one hand, it gave us the Moon, which lights up our planet at night. Not long after, another asteroid would strike Earth, somewhere around the Yucatan Peninsula to be precise. The impact of this collision created a huge amount of dust that led to absolute darkness across the globe. It formed a massive 200-kilometre crater known as the Chicxulub crater and killed between 80 and 60% of all living things at the time, including dinosaurs. The asteroid in this case measured 12 kilometres (7.5 miles) in diameter and was said to be travelling at a speed of about 43,000 kilometres per hour, 27,000 miles per hour. Yet, it created up to 100 teratons of TNT, equivalent to 1 billion times the power of the atomic bomb the US dropped on Hiroshima. Scientists estimate that around 325 gigatons of sulfur in the form of sulfur aerosols and 435 gigatons of carbon dioxide were released into the atmosphere as a result of the collision. If that were to happen today, no human would survive it. But unfortunately, there are several asteroids like the Chicxulub hovering around space, looking for the next available planet to plunge into. Some of them are classified as near-Earth objects, which means they are closer to our planet and pose a greater threat than those in the main asteroid belt and other areas of space. NASA keeps a close eye on asteroids and other near-Earth objects through the Near-Earth Object Wide Field Infrared Survey Exploration Project, also known as NEOWISE. However, tracking these rogues of the space elements is not enough. It is important to have a structured plan on how to destroy or divert asteroids that are on a collision course with Earth, and that's where the Double Asteroid Redirection Test DART project comes in. What is DART? The DART mission is a planetary defense initiative to demonstrate how kinetic impactor energy can be used to change the speed and path of an asteroid. The project is actually developed and run on behalf of NASA by the Johns Hopkins University Applied Physics Laboratory. NASA's Planetary Defense Coordination Office is credited as the primary sponsor of the DART mission. However, the department is efficiently supported by several local and international partners. They include the NASA Goddard Space Flight Center, NASA's Kennedy Space Center, Lowell Observatory, the US Naval Academy, and of course, SpaceX. First mission. After many years of development, the DART spacecraft launched in November 2021 from the Vandenberg Space Force Base in California aboard a SpaceX Falcon 9 rocket. The object of this mission was quite straightforward, at least on paper. The DART spacecraft was programmed to travel some 11 million kilometres, 6.8 million miles away from Earth and crash into an asteroid known as in the binary Didymos system. But make no mistake, this was no easy task. For perspective, the said target is as big as the Washington Monument. For 10 months, the spacecraft sailed through the emptiness of space, following its own orbit around the Sun and making its way until it got close enough to begin preparations for the collision. 10 days before the widely reported collision, the destructive spacecraft deployed a small satellite called LISA-Cube. The LISA-Cube was provided by the Italian Space Agency for the mission. Its objective was to capture the iconic moment that DART would ram into the Dimorphos asteroid. According to the grand plan, the LISA-Cube would also make a close pass around the collision site to get images of the rocks and debris that are left behind, which scientists refer to as ejecta. Eventually, the D-Day for the collision finally arrived on September 26, 2022, and NASA officials remotely controlled the DART spacecraft to intentionally crash into the Dimorphos asteroid at exactly 7:14 p.m. Eastern Time in the US. The collision was described by scientists as a first-of-its-kind event that holds great significance to our long-term safety and the existence of humanity on Earth. Interestingly, NASA also broadcast it live, allowing people from all walks of life across the globe to share in the special moment. We're embarking on a new era, an era in which we potentially have the capability to protect ourselves from something like a dangerous, hazardous asteroid impact, Laurie Glaze, director of NASA's Planetary Science Division, said. According to NASA, the DART spacecraft was travelling at a neck-breaking speed of about 22,500 kilometres per hour, which is equivalent to about 14,000 miles per hour. Scientists at the control centre erupted in celebration as the DART spacecraft crashed into the Dimorphos asteroid. The mission was completed, but they'd have to wait a couple of weeks to see if the impact of the collision actually changed the direction and speed of the asteroid. However, Alina Adams, DART's mission systems engineer at the Johns Hopkins University Applied Physics Laboratory, was quite optimistic that the process went well. As far as we can tell, our first planetary defence test was a success, Elena said. I think Earthlings should sleep better. Definitely I will. How powerful is the DART spacecraft? So far, the DART mission has cost NASA over $300 million. The spacecraft itself weighs about 1,345 pounds at launch, but after burning fuel to reach its target and releasing the LISA-Cube satellite, the weight was reduced to around 1,210 kilograms at the time of the collision. It was powered by ion propulsion technology, which uses Exion thrusters. Aside from the LISA-Cube, the DART spacecraft was equipped with ultra-high resolution lenses known as the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, or DRACO device. The DRACO camera helped scientists measure the size, shape and geologic composition of asteroids within its range. In addition, the DART was equipped with a navigational toolkit with an advanced directional coding system, a star tracker, as well as a metal oxide semiconductor and an image processor that enabled the spacecraft to calculate the exact location of its target while beaming signals back to Earth through its state-of-the-art antenna. Why is the DART mission humanity's most important space project? In reality, the Dimorphos asteroid doesn't pose a threat to us per se. In fact, some might argue that it's unnecessary, but scientists argue that it's a really important project for our space exploration efforts. After the collision, NASA spent weeks monitoring Dimorphos and found that the impact had changed the asteroid's orbit by 32 minutes. This was seen as a huge success considering that scientists had predicted a 10-minute change in the trajectory. Currently, no asteroid is on a collision path with the Earth, but if the need ever arises, we can be rest assured that we have a defensive mechanism to protect ourselves from asteroid strikes. Alternatively, we could blow up these asteroids, but that would create more space debris and lead to more problems for scientists in space. But thankfully, the DART mission doesn't have this problem. This gives us the assurance to sleep better at night, knowing that the history of the Chicxulub asteroid collision event will never repeat itself again.